All right, welcome to day 13 of distance learning. So we are going to continue working with trig ratios and actually writing equations that would help us solve word problems. So we don't have access to the calculators and going through the process of solving these equations, but we are going to start writing them. So we've done a couple of, if I give you this picture, find or write the trig ratio that would help you find this angle, but now we're going to be looking specifically at word problems. So a very quick reminder, we have three trig functions that we talked about: sine, cosine, and tangent. So sine is the opposite over the hypotenuse, cosine adjacent over the hypotenuse, and then lastly tangent is the opposite over the adjacent. So we will put that up here so we can reference it as we go. We're going to go through one warm-up problem before we look at the word problem. So this word problem is not part of this. SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangent opposite over adjacent. So if you had this picture right here, we can look at the fact that we have a right triangle, and to identify, this would be the hypotenuse. Do you notice there's nothing here, which means we are not going to be using our hypotenuse, which means we're not using sine and we're not using cosine, because that would need the hypotenuse in order to write that, set up that trig function. So TOA, opposite over adjacent. The angle that I have would be this right here. When I'm looking directly across, the opposite angle of that is 5. The adjacent angle is x, so I can write the trig function tangent of 37 degrees is equal to the opposite, which is 5, over what I don't know, which is x. So that's all we're doing. We are just setting up this equation. We're not solving it. We're not using inverse operations. We are just setting up the equation that would help us find that missing value. So that's our very quick refresher. And now we're going to be taking a look at some word problems. So this is a nice word problem, except we're not given the visual to help us solve this yet. So it says a 25-foot flagpole casts a 42-foot shadow. Write an equation to find what angle the sun hits the flagpole at. So we have to get creative and use some art. So we know that a flagpole stands directly up and down. So the first thing I'm going to do is draw our flagpole. There's our flagpole. We would draw a nice flag on here. All right, here's our flagpole. And the thing that we know about this flagpole is that it's standing 25 feet tall. So this is 25 feet here, this measurement. The second thing I know is that there is a sun that's casting a shadow that's going to be 42 feet long. So here is our sun. It's going to be green today. The sun has to be behind the flagpole, right? Which is going to cast a shadow through here. So our sun rays are coming down. So we're going to finish drawing our, and it's going to be a shadow. And our shadow, which would be what's lying on the ground, is 42 feet. And this will be our 90-degree angle, right? Because our flagpole is going to be perpendicular with the ground. So we have a 42-foot shadow, a 25-foot flagpole, but they're asking us to write an equation to find what angle the sun is hitting the flagpole. So when we're looking for that, we're going to be looking for this angle right here. We'll call that x. So I have to decide whether I have to use the sine, cosine, or trig function to figure out what x is. So in this triangle, I notice that I have the opposite and the adjacent sides to this angle. I don't know what the hypotenuse is, which means if I have opposite and adjacent, I'll be using the tangent. So my equation will start out by saying the tangent of my unknown, which is x, would be equal to the opposite over the adjacent. So the opposite, looking directly across, would be 42 over the adjacent, which is 25. That's it. All we're doing is writing the equation. We're not worrying about solving it. We're not worried about moving things around. The tangent of x would be equal to 42/25. We're going to go through one more example. It's going to take me a second to write this down, so give me a second. All right, this time, a kite with a 400-foot string is flying. If the string makes a 42-degree angle with the ground, write the equation to find the height of the kite. All right, so let's take a look at that again. A kite with a 400-foot string is flying in the air. If the string makes a 42-degree angle with the ground, I need you to write the equation to find the height of the kite. So a couple of things that we know about kites. If you are standing there holding the kite, it's very unlikely that the kite's going to be straight up in the air. The wind's going to be blowing it in some direction. So here's our kite. Okay? And it's attached to a string and you're holding it, so the string right here is going to be what you're holding on to. That means that string is 400 feet long. The second thing I know is that the string makes a 42-degree angle with the ground. Again, our ground would be this level part right here. So we know that this angle is 42 degrees. And then they're asking me to find how high off the ground the kite is. Remember, when you have a triangle, when you're finding the height, that height needs to be measured. It needs to be perpendicular to the ground. So what we're really looking for is this piece right here. And that's going to make a right angle because the height of how high off the ground the kite is would be perpendicular. That would be the measurement you'd have to find. So we are looking for this value right here. We can call that x. So now we need to figure out which trig ratio we need to use. And then we're going to go through and just write the equation. So if I'm looking for this side right here, but I have this angle, I notice I have the measurement of the side that is opposite, right? This is the opposite side. And then I have this one up here, which is the hypotenuse. So when I come back over to here to my trig ratios, if I have the opposite and the hypotenuse, the function that I have, or the trig ratio I have to use would be sine. Sine has the opposite and the hypotenuse. Opposite and hypotenuse. So let's set this one up. This time we're going to be using sine. The sine of, and this time I know the angle, so sine 42 degrees is going to be equal to the opposite, which I don't know, that's my unknown, my x, over my hypotenuse, which is 400 feet. So again, all you're doing for this practice on this quizzes is setting up these equations. You're not solving them, you're just organizing your data using the correct trig function for yourself, okay? So if you have any questions, please send me an email. Otherwise, we'll see you again on Wednesday.